Hello, chemistry students. So here we are trying to make some kind of a gas-powered boat or rocket or car. It really doesn't matter. They all work the same way. I hope that you picked one. Now I'm going to make a boat. Now when I do this, remember there are three parts of this process. The first part is my fuel. Now the second part is going to be my exhaust chamber or my nozzle. How do I get the gas to come out of the boat at the right speed and rate? And the last one's going to be my delivery mechanism. How do I manage to mix my fuel so that I get it inside the boat and not like everywhere around my room? So we're going to talk about that a little bit today. Now hopefully you are already in this process. By the time you're seeing this video, we're already almost the end of the week. So you've been experimenting. So let's take a quick look at what I've got going here. Now by this point, you should have figured out that our ratio of baking soda to vinegar is 14:1. Now 14:1, if you haven't seen the video yet, that means you're a little bit behind, means that for 14 vinegars, I'm going to have 1 baking soda. But the question is, 1 what? Now the easiest thing for us to work in is moles, but the problem is I have trouble measuring moles. I don't have electronic anything to do that with. So here at home, how do I possibly do it? Well, what I have done is I've decided I'm going to use grams. So as you can see on this scale over here, I have put together a beaker, and in the beaker, which by the way weighs, as you should be able to see there, 180 grams. So I set my scale at 180. Then I poured in, I knew I wanted to use 10 grams of baking soda. So that means I have to have 140 grams of vinegar to equal it. So I went ahead and said, well, what's 180 and 140? Well, 180 and 140 are going to equal 320. So I set my scale at 320. Then I added vinegar into my beaker until I got that measurement. Now this is okay for the first time I do it, but after that I don't really want to have to be weighing it every time I do it. So now I need to look at a measurement. Now I can see that I'm not quite at 200 milliliters. So I'm at about 150 milliliters in this container right there. So since I'm at about 150, I know approximately how much I need to pour into this every time that I want to fill my container. So what do I do next? Well, I'm going to weigh out 10 grams of baking soda. So with 10 grams of baking soda here and 140 grams of vinegar, I now have a 14:1 ratio vinegar to baking soda. So that means I should get a complete reaction, which means when I'm done, I have made the most CO2, carbon dioxide, I can possibly make. Okay, now once I get that, the question is, all right, what do I put it in? Now I could put it into a little bottle like this, and I could just take the cap off, and in the cap I could put a hole. Now I brought a 14-penny nail to the party, and I could just poke this 14-penny nail through the top of this and then say, there you go, I have a nozzle. Is that going to be too big? Not big enough? Too small? I would have to experiment. Now, if we were at school this week, that's all you guys would be doing. You'd be running out to our test track and you would be making these, and you'd start with a small hole and you'd just make it bigger and bigger until it was going the speed you wanted, and you go, wow, I'm using it, it's getting me all the way to the end of my track. But since we aren't together, this is one possibility. But there's a separate problem. See how small this opening is? Trying to get my baking soda into that little opening could be a problem. So I've decided I'm going to take care of 2 of my problems by choosing the right vessel. So what I did was I went and got a Gatorade bottle. Now this particular Gatorade bottle comes with a cap that allows me to open it and close it. Now as I have it all the way open, that's going to be as large a hole as it can get, but if I don't open it all the way, I actually am making the nozzle smaller and smaller. And as you'll notice, the size of the opening is much bigger than with my water bottle. So now I can put my vinegar and my baking soda in here much easier. Okay, now we have one other thing that we have to consider. How are we going to manage to not get them to mix in here and all the gas come out before I even get the top on? Well, simple physics is going to help us with that. So here I take my vinegar and I pour it into my vessel. Now the reason I'm putting my vinegar in first is because vinegar is a liquid, and a liquid conforms itself to the shape of the bottle, unlike a solid. Now my baking soda is a solid, so when I put it in, it's going to be in whatever shape it's in. So this way, I can actually tilt my bottle and I can get myself an easy access here without mixing. Now I take some of my baking soda. Now, if I had done this ahead of time, I would have gone ahead and I would have measured this out to get a weight. Instead, I'm just going to put some in here. As you can see, because I'm dropping it at the top of the bottle, there's no mixing going on yet. So I can put in as much or as little as I want. And look, I now have my vinegar and my baking soda in the same vessel without them reacting yet. Now once I put on my lid, I've closed my top, the gas will be trapped inside. Now I still don't want it to go crazy, but if I put this out on my track now, I can shake it, get my reaction, and then shoot it down the track. As you can see, I'm getting my reaction. So, try this at home. Pick the right vessel, figure out a way to get it so it doesn't mix until you're ready for it to mix, and then either launch it into the air, put some wheels on it, shoot it down the street, or put it in a track. My next video, hopefully you'll get a chance to see this go down a track. Have a great day.